Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic. Following the fourth pattern, which is parenthesis and scoring, today we'll do the last question, which is longest valid parenthesis. And the difficulty is hard, but trust me, just watch till the end and I will make sure ki you will not feel the same anymore. So let's read the problem statement. The question says ki we will be given a parenthesis and we have to say ki from which index to which index it is valid, and out of all such valid parentheses you have to return the longest length of it. Let's read the constraint. Constraint says the S length can be 0 also and can go till 3 into 10 power 4. Now, why we read the constraint? Because if you are following our pattern wise playlist, then for sure you know ki code beyond 10 power 8 is very risky, it's very slow. And sometimes till 5 into 10 power 8 operations also get submitted, but for sure beyond that will give us TLE. And as the end here is 3 into 10 power 4, so definitely square of it. Suppose if you are writing any brute force code, then it will become n square and then it will become 9 into 10 power 8, and for sure that will give us TLE, hence we need to optimize. Okay, so let's try to understand the problem. Here it says ki, as you can see in this given example, till from first index to fourth index, this is valid, correct? So you have to return the length of it. Okay, so how you calculate length? Basically, if you have left pointer here and right pointer here, you do right minus left plus 1. Okay, that too we will do. But how to check if this is the valid or not? Okay, so the very first brute force code which comes to our mind is, but you should have followed the prerequisite, which is valid parenthesis. If you have done that problem, then only you can think for this problem. Trust me, without knowing that, don't jump onto this problem, otherwise it will definitely feel difficult. Okay, so I am assuming you already know how to check valid parenthesis. Now the thing is, for the brute force approach, I am saying ki this is my I index. Okay, so let's take one thing. Let's take the substrings one by one. So first take only this. Second time, let's take this. Third time, let's take this. Fourth time, let's take this. Fifth, next time, and see if this was valid. No, it was not. Now this valid. This valid, yes. So calculate the length and save it. So length is 2. Next time, no, it is not valid. Now, yes, it is valid. So length 4. So maximum 4. Save it. Now, no, it's not valid. Okay, leave it. Now, from this index, this valid? No. This valid? No. This valid? No. This valid? No. Okay. So out of all substrings, like how you generate substrings, right? With the help of I and j pointer. First, we will run the for loop for int I is equal to 0 to where? Let's suppose last index and I plus plus. And then you will run the second for loop for int j, and where j will always start from I and j will run also till n and j plus plus. Now in this you have to take substring, correct? So basically you will make a valid function. Okay, so if you will call the valid function, if valid, you will send the string, you will send the I, you will send the j. Okay, if that function returns true, then definitely this length is valid. So you have to return the maximum length. Okay, so max length you will initialize with 0, and somewhere here the max length you will update with what? Math.max of what? Max length is maximum, or this j minus I plus 1 is maximum. Very simple. And this, how to make this valid function? This, for this you have to watch the previous video, which is valid parenthesis. Then you can make this. But there is small difference between that valid parenthesis question and this question is, in valid parenthesis you have all different types of parentheses, but here it's only small letter. Okay, so here we can do the space optimization for this much, for the valid function also. So in short, how you will write the valid function? Definitely if you are standing at a closing bracket, then for sure it's not valid, right? But if it's open, yes, it is valid. If it is closed, yes, if it is. So hence valid parenthesis question is a bit different compared to this one. Okay, because of the only thing key here, the parenthesis only belongs to a single category, which is small brackets, correct? Yes. So now this, this function can vary, and how you can make is, let me tell you. So suppose you have bracket like this. Okay, so the idea is very simple. if you get any such closing bracket, okay, you will have a count variable. Let's say count is equal to 0. If you get any such closing bracket, you will decrease the count, okay, and if you have any open bracket, then definitely you will increase the count. Very simple, okay. So at first, what we have closing, so we will make a count 0 and we will reduce it, so it will become definitely -1, okay. And whenever your count becomes negative now, it means, you can say ki it means there are extra closing bracket compared to open brackets. Can I say this? Why? Suppose you have this, this, this. So count 1, count 0, decrement, and count -1. So if your count is negative, for sure you have extra closing bracket compared to open bracket. And if you are standing at this last index, for sure now you will move ahead. So in any condition from 0 index to this index, this much substring is not going to be valid ever. Can I say? Because you cannot go back and add it, right? Because you're moving ahead. So hence, if your count becomes negative, you can say ki no, it's not valid answer. Again, start incrementing your count from 0. Okay, very simple. But here, as you have to check ki the given substring is valid or not. So what you will do, if at any time your count becomes negative, so you can say no, this whole string is not valid. Okay, don't get confused. Although the question was about finding what? The longest valid. But as you can see, we have broken down the question into parts, like we will generate all such substrings and we will send in this valid function. And now this valid function only tell me ki that particular substring which I have sent in that function is valid or not. So suppose this substring I have got in the valid function. So basically I have to check ki if this whole is a valid substring or not. Okay, or valid parenthesis or not. So for sure the count is negative, means at starting only I can say yes, this substring is not valid. So is valid function will get returned as false, and definitely that maximum length we will not update. Okay. Now let's take a valid case and let's see how we'll calculate for it. This is valid, right? So as it is open, so count will become 1. Again, as it is open, the count will become 2. As it is closed, count will become 1. As it is open, count will become 2, 1, 0. Okay. So at the end, if your count was 0, you can say it's true. Why not positive? Why not positive? Suppose you have like this. Is this valid? Count will become 1, count will become 2, and you will decrease the count because you have a closing bracket. So in total, your count is 1. So it means if your count is positive, you have that many open brackets left over. If you have count negative, it means you have that many closing brackets extra. Okay. But if your count is 0, it means you had actually found equal number of positive, like open brackets, and equal number of closing brackets. Okay. So now with this, we can write the code also. So here is the code I have written for you all. First, we will basically initialize a max and n variable, and we will run the for loop from I, and second for loop from I plus 1. Okay, this we can consider how we want to send in the valid function. Okay, so basically a single length cannot be a valid parenthesis, right? So to check a particular parenthesis is valid or not, so for every open you need a closing bracket. So hence minimum length you will send 2, right? So that is the reason I will start from 0, but j will start from I plus 1. So here we can run till n minus 1 also. Okay, I hope you will get that. So now what we'll do, why we will not increment j as plus plus, no, we will increment j as plus 2, because we are considering one open, one close. So for sure we are checking in the pair, right? So for every pair there will be like the pairs will be available at 2 distances, correct? So basically what we will do, from I to j, correct, and as it is excluded in the function, so that's why I have written j plus 1, okay, but it is from I to j. We'll send is this in this isValid function. If that function returns true, then so we will update our maximum length by j minus I plus 1. Now let's see how we are doing in the function isValid. We will initialize the count variable. We'll run 1 by 1. If it is open, we'll do count plus plus. If it is closed, we'll do count minus minus. But after count minus minus, if at any point the count becomes negative, it means we have found extra closing bracket. So we have to return false then and there, because that substring is not valid parenthesis. And at the end, if your count is not 0, means if it is 0, then only you can say yes, you have found equal number of open and equal number of close. But if your count is positive, it means you have extra open for which you don't have equivalent closing bracket. So at the end, return true only if your count is 0. Okay. Obviously, we can run this, but the time complexity will be, first of all, O of n square to generate all such substrings. Correct. And inside it also, you are calling this to check what? If that substring is it is valid parenthesis or not. So for sure, further O of n time complexity it is taking. So in total, O of n cube around. Correct. So if you submit this code, definitely this will give you TLE. As expected, TLE. Correct. So now how can we optimize it? Okay. So definitely, instead of calculating the substrings, we have to think for something else. Okay. Whenever we talk about parentheses and whenever we to check valid or not, obviously we want to go back and we want to check open. Do we have open equivalent open brackets for closing brackets and so on? So hence stack data structure we have to use. Correct. But we have to check the length here. So how can we do? Earlier, when we have to check the valid parenthesis, in the stack we were sending what? Brackets. But now we have to calculate length. So for length, definitely index is going to help me. Because if you are at particular index, the previous valid index will help you to calculate the length. Okay. So in the stack, that is very simple. In the stack, instead of saving the brackets, we will send the indexes. Correct? But how to fill inside the stack? To understand this, let's take a very small example. You have this. Suppose for this, you send 0 index and now you are at first index. Correct? So definitely from the stack, you would like to pop. Why? Because for sure in the stack, if it is a closing bracket and if it was valid, then you should have inserted this index for this. Correct? Why I'm saying? Because here you are not checking any valid functionality outside. You will check in the same function, okay, in the same for loop, correct? So definitely if this is a valid, so for this closing, there should have been an open for which you have inserted. Very good. But what if it was not valid? Means, what if you have only this? So for sure for this, you don't know na, it is valid or not. So for this, you will imagine ki, hey, for this closing bracket, definitely I would have saved my open bracket. But in the stack, you have nothing. So when you will try to pop, you will get error, correct? So hence, for the safer case, what I will do is, I will insert a -1 here. Okay, why -1? Because we are saving the indexes. And from 0 to all positive indexes are valid. -1 is the only index which is not valid. So that is the one of the reason we have inserted. Second reason will be to calculate the length. Like from j to I, when j and I both are valid, so how we calculate? J minus I plus 1, correct? This is how we calculate the length. But as we are with -1 na, so we will just calculate by j minus I. Okay, I'll show you how. Correct? So the idea is very simple. First we'll insert the -1. I told you the reason. And now going forward, if it is an open bracket, for that we will send the index here. And if it is a closing bracket, for that we will pop the element. Okay. So what's the first value? It's closing bracket. Can I say? Okay. So if it is a closing bracket, and we will assume ki the element present here is my open bracket location. So I'll say simply pop it. Okay, I popped it. But see, I only inserted -1 so that in this case I won't get error. But now I'll check ki suppose if this was valid, I am here. Okay, 0 index. Suppose here also we have something. Okay, so suppose the index for this is 2. Okay. So what I'm saying is, if I am present here, so definitely after popping this, how will I calculate the length? Definitely with 3 and with 1. So 1 should be there. So what I'll do, 3 minus 1, I'll get the length. So basically, if I found a closing bracket, for sure, an element before it, it should be open and we will pop it from the stack. And to calculate the length, definitely we know that 3 and 2 index is valid, correct? But if the in the stack, we would have saved the previous index 1. So how we will calculate the length? If only 3 and 2 was there, so we would have calculated 3 minus 2 plus 1. Right minus left plus 1 length. But as we know, in the stack we have 1. So we will do 3 minus 1. Correct? So this will also give me the length. But when you checked here and you had -1, you popped thinking that this was the open bracket location. But after popping it, there should be some element in the stack. But if the stack is empty, it means you found a closing bracket for which you don't have the open bracket. See, it might feel a bit confusing, but trust me, just listen me once properly and I'll clear everything. Okay? So basically, for this, we had -1, and once we encountered a closing bracket, we popped and we checked, hey, we have nothing in the stack. Then it means this was not a valid parenthesis. Okay? But now we want to calculate the length for the next ones, So I know whenever I will reach to a closing bracket, then I will calculate my length. But I will calculate my length with open bracket? No. This I will pop, That's what the rule is. So I want to calculate the length with this. So what's the index for this? 0. So I want to insert. So what I said, key, simple. If my current index character is equal to open, okay, then you will simply, in the stack, you will push the index I. So you will read like this, s of I, s dot character of I, okay? I'm just writing like this. Else, if it is a closing bracket, so for sure, the first element you will pop, considering that this was a location for the open bracket. But after this, if stack is empty, then it means for sure, like how in -1, it means for sure that that parenthesis was not valid. So in the stack, we have to push 0 for the next calculation. Okay? Else, we will check how we'll calculate. Okay. So we'll put 0. Now again, this is open. So for open, we'll put the index. Now we'll move to the close, and this index is 2. But as we'll come here, else case, we'll pop the very first element and then we'll check, is the stack empty? No. So means this is valid. From 2 location to 0 location, how can we calculate the length? Obviously 2 minus 0, because this is a 2 length which is valid. So in the else case, we will update a max, where we will update math.max. Current max is maximum, or this is maximum. How we'll calculate? I minus stack dot peak. I hope this is clear. Correct? Yes. After coming outside, we will simply return the max. Okay? Very simple. Now, what we'll do, we popped this. So let's remove this. Correct? With the help of 0, we have calculated the length. Now, again for this, 0, 1, 2, 3, 4, 5. Now we'll insert 3. Now the moment we will encounter 4. So for 4, we'll pop this, like, because in the else case, closing bracket found, we will pop it. Is the stack empty? No, we still have 0. So with the help of 0, we'll calculate the next length. As you can see, 4 minus 0 means 4. And anyhow, this much length is valid. Correct? So now what we'll do, we'll move ahead and we will, what is this? 5. We'll pop. Is our stack empty? Yes. Anyhow, it is not valid, right? Yes. No. So hence you will come here, is stack empty? Yes. So in stack, you will push 0 or you will push current index. You will push current index, right? Because what if you have, after this you have valid or longer length, 8 length. Then for sure you want to calculate the, valid length as per this index, because beyond this is valid. Here it is valid, but because of this, it's not valid. So hence, instead of 0, you will push the current index, which is definitely I. I hope this is clear. So let's write the code for this. First, we'll make the stack of type integer. Let's name it stack is equal to new stack. Correct? Now first, in the stack, we want to push -1. Remember? Now we'll run the for loop for int I is equal to 0, I less than s dot length and I plus plus. Done. Now what we'll do, we have to check if this s dot char at I is a open bracket, correct? Then simply in the stack we have to push the index, no doubt. But else, if it is a closing bracket, so simply we will pop the very first top value, saying this might be an open bracket for it. If it is open, then for sure the stack should not be empty, right? But if the stack is empty, means that was not a valid parenthesis, and now in the stack, as the stack is empty, so I want to push the current index, okay? Or else if it's not, then definitely I want a max variable, okay? So math.max, I'll initialize also max, comma. How to calculate the length? Definitely I minus a stack dot peak, top element, remember? And here we will initialize a max variable with 0. Yeah, 0. Now after coming outside, we can simply return this max as our answer. So let's try to run this. My bad, it should be open bracket, right? This is not a silly mistake. So sorry. Yeah, now it passed. Now let's try to submit this. Definitely it will get submitted. But what's the time complexity? As you can see, we are running a one for loop, so definitely O of n here, and we are iterating at every index at once. But if we talk about space complexity, as we are taking the extra stack, so definitely the space complexity will also be O of n. So this was your Java code, and here is your Python code. If you are from Python background, logic is very similar. And here is a C++ code with the same logic. Time complexity O of n, space complexity O of n, which is far more optimized code compared to the brute force one. But is there any further optimized version? Means can we, like in parenthesis, we are continuously doing the space optimization, right? So can we do similar here? Yes, we can. Let's see. So for the space optimization, the idea is very simple. If you are getting this open bracket, okay, so let's call it left. We will increment left by 1, okay? And if it is a closing bracket, means from right, like right side, like when you are writing the bracket here, this is your left, this is your right, right? So as per that theory, I have named it, this is right plus is equal to 1. So whenever we are getting a closing bracket, we'll increment right, and whenever we are getting open bracket, we will increment left. If like at whatever point, if left is equal to right, it means there are equal number of left and right. But at any time, see, if you have more left and one, right less, correct? So there can still be possibility because you are going towards right direction. So you might find, okay? So for this case, we cannot say it is wrong. But for this case, I can definitely say it is wrong because going forward, other brackets might be valid, but for sure, this much won't be valid. So hence, can I say if at any moment, if my right is greater than left, then for sure, I have to reinitialize my left and right with 0. That's it, okay? And we will iterate on a for loop. So for, we will read character ch one by one in s dot to char array, okay? Now, if this ch is equal to what? Open bracket, then this is left. So we will do left plus plus, else we will do what? Right plus plus. Very simple. Okay. This is for reinitialization. Before that, we have to check कि if our left is equal to right, then we can say it is valid. And if it is valid, so in the max answer, what we'll do, we will, update the max, correct? Mat dot max, this current max is maximum or else? You tell me. If you have this, so left 1, right 1. So what should be the length? 2. Now tell me this. Left 2, right 2. What should be the length? 4. Now tell me for this. Left 2, right 2. Left 2, right 2. Length 4. So can I say for length, I can simply say 2 into right or left also you can write here. No problem. Okay. Because anyhow both are same. So max we will update. So we will write this in else condition. Okay. Else if condition. So very simple. One by one we will iterate. If it is a closing bracket, we will do right plus plus. If it is an open bracket, we will do left plus plus. Now, if both are same, means it is valid. So we will just update the maximum length. If it is not, so there can be two possibility, left maximum or right maximum. If left is maximum, then we don't know, like going forward, there might be the possibility, for example, left is maximum. So we are going forward only. So it might become valid. So we cannot say invalid. Invalid, if you are saying invalid now, so from then and there, we are reinitializing our left and right with 0. Saying ki, hey, till now we have not found anything, go forward. But this is not correct, right? Because this whole is valid, right? So hence, that is why if left is greater than right, we are not saying anything. But only if your right is greater, means for sure, going forward, anything can be valid. But this part cannot be valid, correct? So hence, we are saying reinitialize your left and right. Now going forward, check if others are valid or not, but this much to not valid, like this much length is not valid. Done. And at the end, after coming outside, we can simply return the mark. It was easy, right? But what if I'll tell you this much is not enough? Let's see how. Suppose test case is open, open and close. Okay. So definitely you will calculate left. Left will become 1. Now 2, when this will move forward to this. And now once you will move ahead to this, your right will become 1. So it means in the whole journey, like when are you calculating your total value, means the length? Whenever you are getting this left is equal to right. But when you iterated from left to right, you have never found that. You were waiting for one more, correct? Because you found 2 open. So this 2 left value will always be equal to 2 right values. But in this, so you have only 1. So you, like, that situation will never come when your left will equal to right. So hence in this case, so it will say ki no such valid parenthesis, means no length. But it's not true now. What should we do? Think. Yes, pause the video and think. What if we would have started from the right side? Think again. Idea is very simple. If your left is equal to right, then only we will calculate. But if we would have started from right side, so definitely we will have right is equal to 1. Now we will move to this. We will have left is equal to 1. And now at this time left is equal to right. So definitely we will calculate max is equal to 2 into left or right, whatever. So now left and right both are 1. So 2 into 2. So now this will say 2 as a maximum length. Now we will move forward definitely. And this time again left will become 2. But no matter. So it means I can say ki see, I have to iterate from left to right also and from right to left also. And whatever will be the maximum answer, that we will return. Yes. That's it. You are done. But one more thing. Very simple. The thing you have written here now, like the false condition, ki if you are iterating from left to right, means if you are iterating from left to right and if you found extra closing brackets, then for sure going forward, this much part will never become true, correct? But it will become vice versa when you are traveling from right to left, okay? How? Suppose you found this 2 open. So definitely going forward, there can be possibility you will get 2 close. Correct? But what if you will get like this? Then going forward, even if you have anything valid, but this part won't, like, it cannot become valid, right? So what is this? This is left, right? So hence, instead of right greater than left, while iterating from right to left, you have to say if left is greater than right, then you have to reinitialize. I hope this much part is clear. If not, please go back and play the video again. I hope then you will be able to understand, because see, on the very first go, we have learned 3 different things. Very first was brute force, definitely. There also we tried applying the smarter approach to calculate if the parenthesis is valid or not. Second approach was also a bit difficult if you are not aware, like, much aware of stack. And this one. But trust me, all 3 solutions, you just need to, write into the copy. Like, don't just blindly watch the video. Then though you will for sure you will forget. Because coding, either it is DSA or LLD or anything, until or unless you will write on your own, you will never going to understand. You will just feel like, yes, you understood and you can do. But the moment you will, sit on yourself to write the code, you won't be able to do it. So please, it's my humble request. Don't just blindly watch the video. Make a notes, take the screenshot. If not now, later. But please, try writing the code on your own. If you are new, pen and paper is the best approach. And if you understood on copy, then definitely you can go towards the editor. So now understood, we can directly write the code. So here is the code. First, we will initialize the left, right and max variable. And at first, we will iterate from left to right. So we will run the for loop from 0 to last. If it is an open bracket, we will do left plus plus. If it is a closing bracket, we will do right plus plus. Whenever the left and right will become equal, we will calculate the max value with this formula as said. And if at any point your right is greater, then for sure it's not valid. We have to reinitialize. Okay, this done from left to right. Whatever is the maximum answer, we already saved. Now again, we will reinitialize the left and right for this different iteration, which is from last index to first index. Means we are coming from right to left. Same formula. If it's open, means left plus plus. Close means right plus plus. Whenever they are equal, means we will calculate. And when left will become greater than right. This part I was saying it's vice versa. In left to right, right is greater, it's not possible. If from right to left one condition, if left is greater, means it's not possible, it's invalid. It's invalid means it does not mean that we have to, invalidate the whole substring. No. Going forward, we might find different pattern, different part which is valid and have longer length. So hence we will just reinitialize the left and right, saying it till now whatever you calculated now, erase it. Now move forward, because till now it's not valid. And that's it. At the end, whatever is the maximum, we don't know. We will get the maximum from right to left iteration or left to right iteration. So whatever will be the maximum, it would have been saved in the marks variable, and we will simply return that. So now let's try to run that. If we talk about time complexity, definitely we are running this 2 for loop. So O of n, which is O of 2n to be exactly, but we call it linear only. And talking about the space, we have not used any such extra space. We just use variables, which is for sure constant. So this was your linear solution. Talking about which is faster, stack one and or this one. See, both are similar. The only difference is in stack, it uses extra space complexity. But in this one, we have not used any extra space. But as you can see a little bit, this code is a little bit faster because of the stack inner implementation. Because it uses, like, it's synchronized and it has locks because of thread safety. So that is why using stack will make it little slower. But still, if you write the stack code in the interview, it's totally fine. Until or unless the interviewer asks you to, further optimize it, like, can you do the space optimization? Then think for, okay, he wants to listen the inner implementation of stack. And if somewhere the space optimization is possible, then definitely you have to do for it. Remember, in every question, it is not possible to do the space optimization. Okay. So this was a Java code, and if you understood, here is your Python code if you are from Python background with a similar logic, and here is your C++ code if you are from C++ background. So if you understood the brute force, the stack optimization and the space optimization code, then only you are eligible to go in the sheet and then mark the last question of this pattern as done. So I hope you have understood the parenthesis and scoring pattern, and till now we are done and we are left over with 3 more patterns that we will cover for sure. Until now, if you have any doubt, please do let me know in the comment section. And if you understood, guys, please, that also I want to listen from you all. Understood, submitted, or whatever is your feedback, all are welcomed. And if you guys are new to this channel, we are following this sheet. I'll add this sheet and my social media links. I'm very active on Instagram and LinkedIn. I will add the link in the description. You can check it out. And that's it for today. Let's meet in another video with some more interesting questions, patterns, and topics. Till then, keep learning. Take care of yourself and your family.